strategy and planning team, but we've otherwise known as the Weather Resilient Climate Action Team. So we kind of get involved with schemes that sit outside of BAU for normal asset teams. Things that are maybe a little bit harder to fix. We kind of come in and we can look at it more in a holistic approach, which is where Chipping Sodbury came in. So yeah, briefly, just want to go sort of an overview of the site and overview the flooding mechanisms, because I think to understand what we're doing, you kind of need to understand what the problems are to begin with. And then, yeah, we've broken it all down into a bit of a phased approach of stuff. So we'll run through some of that. Apologies, I've got a bit of a cold as well. So if you see me run to get some tissues, I do apologise. So Chipping Sodbury, if you are not aware of where it is just east of Bristol. The site is roughly from the SWB. The main bit of the site at the moment that we're looking at is between 101 mile, 160 yards to 104 mile, 990 yards. That's kind of expanding as we develop our knowledge of the site a bit more. I guess that's kind of a zoomed view of it, showing it's in North Sodbury. Next slide, please. So I guess the main figure to why we've got involved is just here. So over £10 million in Dredge Lake costs between the winter 23 to 24. It's about 6 months. We shut the railway for around 50,000 minutes and yeah, £10,000 delay cost. So the drainage team were looking into it. The drainage team have got a hell of a large asset base. But as I said, we sit outside of the asset team, so we've kind of got the opportunity to really delve into whole site, and we don't just look at the drainage asset. We'll look at E&P, we're looking at trap, we're looking at how the pumps work, we're looking at basically the holistic site, and that's why we've got involved on this side. Next slide, please. It's not been a problem for the just winter 23-24. This is a picture from back in 1902, so it shows that it's been an ongoing problem, and it will probably be an ongoing problem. Also shows a steam train actually going through the water, which you can't do now. So maybe we go back to steam trains, might be more resilient. Next slide. So yeah, overview of the flooding mechanism is there's three types of flooding mechanism here. We've got one which is groundwater. So the tunnel itself is dug, been built through three principal aquifers. There's oolitic limestone through there, so you can get up to about, we think, haven't been able to get the actual data for this yet, but it could be up to 2,000 litres a second comes through a great spring into the tunnel. That then also comes out through the tunnel into Chipping Sodbury Cutting, so that site that we're saying that floods a lot. We've then also got pluvial and fluvial types of flooding as well. So even though we've got limestone through the tunnel that's overlain by clay, all the surrounding land around to where we flood is clay. So as soon as water lands on that, it just flows to the lowest point, which unfortunately is the railway. The reason why 23-24 was so bad was, if you cast your mind back 2 years, summer of 2023 was really, really wet. So that groundwater table was already really high before we hit winter. And then we had an extremely wet winter as well. Obviously, the groundwater table was really high, so loads of water's coming flying out of the tunnel. We've then got river levels are really, really high. So they then start overtopping and start down to the railway. And also loads of rain on saturated ground, or pretty impermeable. Again, goes to the lowest point. Running theme here, it's the railway. Hence why we had so many issues. And I guess the main figure at the bottom there is to close this section of railway is £750,000 a day, so it's quite expensive. So to explain how all those three mechanisms work together, so this sort of red circle here is me trying to show where the groundwater is coming out of the tunnel. So the red arrow is, it's all collected in a 6-foot drain, so it's an 800 mil brick arch drain that runs all the way from the east end of Chipping Sodbury Tunnel, so somewhere over here, and all the way down and outpours out here. Then got the green lines, which showing all of the fluvial types of flooding that we get, and then we've got fluvial flooding. So there's three water courses that cross the railway. So if we work high mileage from the east, from the west, sorry, we've got Kingrove Stream. This runs through a culvert and runs, and where the lagoon outfalls into, which I'll go into information a bit more. We've then got a siphon here, which is a tributary to the River Froome, which sometimes can overtop. So it runs into the crest ditch and then flows down to track. Those arrows there are showing. And then you've got the River Froome here. So this is part of some works that was done in 2017 to try and make the railway a little bit more resilient. So part of the WEP, we have to raise the level of an aqueduct because the electrification line couldn't fit underneath. So you've kind of got the aqueduct that runs there, and then the balancing pond here, which you can't really see, so apologies. That's what this dotted line is trying to show. The balancing pond, which is set, so make sure we don't put too much water over the new aqueduct or any more than what used to go over. Next slide. I'll have a bit more information on that. So this is during the construction. This is that new balancing pond. So the old line of the Froome ran along this trees here and down sort of parallel to the track and run down a flume towards the track. So the old aqueduct used to run about here. We've had to move it, then raise it by about 1.5 meters. Therefore, that gradient of the river now is a lot flatter between here and here, because obviously we've had to raise it 1.5 meters. So as I said before, this section here is a weir. That is set. Make sure that no more water goes over the new aqueduct than the old aqueduct. So as you can see, this new aqueduct is rather quite large. You might recognise it as well. It's not actually an aqueduct, it's a footbridge. Because during WEP, we didn't have enough money to get a proper aqueduct, so we had to use a footbridge instead because we had it readily available. One major issue with that, though, is its bowed. So technically, in the middle of this aqueduct is actually higher than it is at the inlet aqueduct. So a few issues here with this as well. And this is just some flow monitoring we've installed on the side as well. So that was in 2018. At the same time, this was being built. This was completed in 2017, which is the new storage lagoon. It's probably a good point to point out now. Whilst they were being constructed at the same time, they were not linked in any way. So as I was saying, this whole site is a system, but until we got involved, the site wasn't looked at as an entire system. Same as this. This new storage lagoon wasn't really thought about in terms of the stuff that was going on with WEP. So there was an older storage lagoon which was constructed about 2004, and the site of the old Sodbury station. In 2017, it was constructed as a new one, which is 11 million litres. I guess another issue we've got at the moment is technically it's not a Network Rail asset yet. So even though it was constructed 8 years ago, it's because of handback contract issues, still technically not ours to manage yet. Which is why I've been told off a few times for trying to change things, but it's technically not a Network Rail asset. We're trying to make things better, so it's all good. And again, just to help you understanding, this is a real basic drawing to try and explain how all the different bits of drainage on the track interact. So that's the portal, and then that there links to that bit there, just try and make it a bit easier to see. So the red line is your 6-foot drain, which comes all the way from the tunnel, as I said, to the Kingsgrove stream. You then got 2 orange lines which show the up and the down cess drainage. And the down cess, there's a 750 mil drain, which then turns into a 600 around that here. That then goes all the way down and drops into a culvert here, which is 1200 mil, and then it runs directly into the lagoon. Up does the same thing. It runs all the way into there, but it's more of a 300 to 450 mil sort of clay pipe. This sort of slightly darker orange line here is just a cess ditch, so it collects any excess water and runs into a trapezoidal ditch, again, into our lagoon. That's sort of how all of the sites sort of interacts at the moment. As I said, we took this with a phased approach. So we started it with a phase 0, named phase 0 because none of the assets were really functioning as they should have done. So phase 0 was getting the to work as they initially were designed to work. So that was taken sort of cleaning, jetting CCTV, so basically doing drainage refurb work, connecting a catch pit at the bottom of where that balancing pond, where it then flows down to track. That catch pit there wasn't fully connected. I'll show you that in a second. So that's more of a renewal activity, that one. Then we did some work on the pumps and clear vegetation from that new stream that was built on wet work. Again, heavily vegetated. That was all completed roughly October last year. Phase one already started around about September, October last year, so a bit of an overlap, and we are now heavily in phase one. That is flow monitoring all over the site, doing some flood modelling, creation of a playbook. This is what we're working with control and all the maintenance teams to understand what we need to do to their assets to make them more resilient. So I'll come on to a bit more in a bit. A bit more refurb work and removing some restrictor plates and doing a track lift in 4 weeks' time. Phase two, we'll look at delivering in CP7, year 3, year 4. A couple of different measures on there. So this is a bit of a graphic to show you what phase 0 was. So we've got some of the jetting and cleaning, raising catch pit lids. So this downset here, we actually didn't have any catch pit lids at all. So we couldn't actually look at what that drainage was looking like. Didn't know it was blocked. If there's anything in there. Fortunately enough, there's a lot of water flows through, so it does clear a lot of the debris out. So there wasn't anything in there, but at least we can get in to check a lot easier now. But I was saying here, so you've got this water comes down, flows to the aqueduct. When the water in that stream gets too high to go over the aqueduct, or make sure that we don't put any more than 1,550 litres a second, because that's what the old aqueduct could take, flows to the balancing pond. The balancing pond there outfalls to the old line of the through, down flume drainage, down into the track drainage. That then connects with a 600 mil internal diameter drainage pipe. However, to click the next slide, that's kind of what it's connected to. That is a look from the catch pit, and then you look that way, you look towards high mileage, all of about 10 yards, it was blocked. So water obviously couldn't get anywhere. Next slide. That meant when water tried to get in, as soon as that drainage pipe was full of capacity, which takes probably about 3 seconds for it to be full, it will then surcharge to track. And this is why we're getting all of these floodings. This is all from early last year, saying those £10 million in Treasure Lake costs. There's some of the pictures there, or some of the issues we're having by we could run trains. So that is sort of part of phase 0. So this is the new catch pit now, obviously 1,200 mil diameter, 1 to 2 meters deep. So fully connected now as well, CCTV'd. We now know that connects in and fully drains down to the lagoon. I mentioned as well about vegetation in that new stream that was created. There should have been, vegetation should be cleared once a year, so on MST. So the maintenance team should go out there and clear vegetation from that stream. However, it appears that it wasn't done for the year before when we took over this, so it looked like it's about 2 years worth of growth. That is the stream there. I promise you, that is the stream there. And again, that's the aqueduct looking back towards upstream. See why we're having issues. So this here, as I mentioned before, is the weir at the top of the balancing pond. So obviously we've got so much vegetation that any amount of rainfall, soon the water level was just too high. It'd always just start flowing into this balancing pond, which then ultimately came down to track. So we're having to take too much water in the track drainage system. So we've now cleared the vegetation, and it looks a bit more like a stream again. So the first picture, I went, oh look, there's a stream there. That is that one there. Okay, so it's now looking like something you can run water through. So this should now be on a yearly MST to keep the vegetation levels low. It's already starting to get overgrown. That's kind of you're going to get in these kind of environments. That's why in about September, October every year we clear the vegetation. Unfortunately, the week after we put in that new drain, that catch pit, showed you a picture of a couple of slides ago, we then had two storm events, which were somewhere between a 1 in 50 and a 1 in 100 year event, 4 days apart from each other. So whilst we were singing from the rooftop saying, "Oh look, we've made it loads better," we then shut twice in a week. So a little bit of egg on my face. But these are the pictures of the lagoon from the EA camera. And so you've got the inlet pumps there, and the outlet pumps fall down somewhere here. So look at this picture here. That's the inlets there. So we said here, the downline's already shut. So you've already got water above the top of the rail, yet you've still got 50% capacity within this lagoon. We were looking at that thinking, well, that doesn't seem to add up. What's going wrong with that? So we did some digging. So we've got some inlet pumps into the lagoon, and everyone told us that these are pointless. They've only run 4 minutes in the 8 years they've been installed. And just as a reminder, that's the down, that's the up. So it runs through here and then drops down into this culvert and it runs across into the lagoon. Slide. This is a few of these graphics, by the way. I do apologise. Artistic skills are not my strong point. So you've got the UTX that runs through into the lagoon. This is then the chamber, just sort of that yellow circle you can see in the last slide. That's the lagoon. So normally gravity fed, it would just keep throwing these through the UTX into the lagoon. Obviously, once the lagoon gets to a certain level, that flat valve will shut. At which point, obviously, water will fill up in the UTX, start filling up in the chamber. The problem we found when we said that the lagoon was only half full but the track was flooded was the trigger to actually start those pumps was when there were 3 meters of water in this catch pit. However, make sure we don't overfill the lagoon. When water reaches the high float switch, that will stop the pumps working. It says not to scale, but the bit that is to scale is the high float switch is lower than the trigger to turn them on. So no wonder they haven't turned on for 8 years, because they're never supposed to work. So one of the first things we did was lower that trigger value. So it went to 1.3 meters. So that was obviously after the first incident we had. Then when we had flooding 4 days later, they turned on for a bit, but not for as long as they should have done. We realised on the back of that, which once water reaches 1.3, pumps will kick in. So then obviously we keep pumping. Once we activate the high, pumps turn off. Once that water level starts dropping the lagoon, you would think the pumps would turn back on again, but they wouldn't, because they were programmed for the water to drop in this chamber past the 1.3 down to the meter and then rise again. So they wouldn't just activate when we wanted them to. So again, a little bit of configuration. It did take the guys about 4 hours to fix that, but we got there in the end. So when we say we're taking a holistic approach to the site, this is what we do. We're not just looking at the drainage aspects, we're looking at how the pumps interact, how it is all supposed to work, and digging into things that potentially no one else has dug into before. And then a little bit of an overview on the lagoon outlet pumps, because again, they did not work as perfect as they should have done. So if we look at this picture here, the inlet lagoon pumps are about here, as you see there. Where we're looking here is literally air. So water will come out of there into Kingsgrove Stream, and so everything will go to the north, downstream. A wonderful diagram. Okay. So lagoon, sensor over the wet well. So once water reaches a certain level in the wet well, the pumps kick in and discharge water into the Kingsgrove Stream. However, the sensor over the Kingsgrove Stream, water level gets too high in the Kingsgrove, pumps again will turn off to limit the chance of us flooding downstream. So obviously, there's lots and lots of properties in the 8 chipping Sodbury downstream. We're trying not to flood them. Obviously, the storage lagoon is there for a reason. There's a discharge rate of 300 litres a second from these pumps. they do have the capability of doing 2,000. If we did pump at 2,000, we would 100% flood. So probably quite annoyed neighbours just downstream of us. Problem was on this second event we had, whilst the pumps were sort of working at that point, we noticed on cameras that the outlet pumps were not working. So for 5 hours, the lagoon was getting full and nothing was leaving the lagoon. So therefore, we were just using capacity in that lagoon, which was great for a bit. Then after a while, the tracks flooded and we're not discharging any water from the lagoon. So this is a dashboard in the pumping room. So in where the outlet pumps are, we've got these dashboards which show you exactly how the pumps perform. So if you had access to this, we would know that the pumps were not working as they should have done when we had that flooding event, that second flooding event in September. However, we didn't have that. We were relying on an EA camera, which was installed about 8 to 10 years ago, which really wasn't fit for purpose. So that's where we have decided to go and do some additional remote monitoring around the site. So we actually have that remote awareness of what's going on, which takes us to phase 1. So we engaged with a company called Purple Transport. So we engaged with them because they don't necessarily have remote sensors, but what they do have is the ability to integrate and assimilate sensors from different providers into one dashboard. And so therefore we can see what is going on across the entire site in one place. To try and do it quickly, we chose to mimic what was going on the site. Instead of integrating fully with all the sensors that were there, we just tried to put a sensor. We had a sensor looking at the pumps working or not. We just mimic that system by putting a circuit sensor on the pumps. Therefore, sense a circuit, sense power going through that wire. You knew the pumps were working. And it's all happened actually pretty quickly, as you can see here. So first informal discussion. A couple of weeks later, we had actually this is what we want to do, and then sort of only a month later, we actually had every new sensor installed and dashboard configured. So this is what it looks like on site. So again, this is kind of where we're mimicking things because that's what sensors already installed. That's what we put in. There are some cameras there. We just put some more so we can see more what's going on. And this is sensor in the downstairs, which is at the lowest point of track. So we now know if the track's flooding because we've got that sensor there. So if a train driver is saying, "Oh, the track's flooded," we can then look at that sensor and go, "No, it's not." You can keep running. So it means we can keep trains running over. Keep trains running for just a bit longer. I won't go into too much detail on that, but that is at the moment all the different bits of flow monitoring, cameras, or any type of monitoring we've got around the site at the moment. So it's on track, off track, sort of low mileage, high mileage, it's kind of dotted everywhere. All those different colours, also different company or different type of equipment. So all of that is being housed in that one dashboard that we'll transform now. And then that's just what it looks like on site. So that picture I showed before of the aqueduct, that's the flow monitor. We've got one, it's about a weir here. This is at the top of the cascades, top of the flume drainage, front of the track. And that's just some of the camera images that we get through. That, by the way, is the siphon I mentioned. Again, this is just as quickly we get through this dashboard, what it looks like. So one of our stopgap, by the way, those little pictures I showed of say what the outlet pumps are doing. That's those two there. We couldn't find a way of looking at them, so we installed a camera on inside the door. A bit rudimentary, but it worked for a bit until we could do something else. And then yes, this is the dashboard which shows us what the water levels are doing, whether the pumps are working or not. This is very much changing as well because people think of something new and suggest something to me. You don't usually take it. Yeah, it ever changes. It's a little bit more of just sort of where the sensors are on site and how it all looks on that dashboard. And then it does create some graphs as well, so you can see over time how watertight is changing, whether it's through, whether it's in the downsets where we know that we get flooding. Yeah, it just gives us that overview of how things are performing. The Atkins flood modelling, which we've done, I've just seen there's a hand up.
Questions at the end. If you've got your hand up, if you could just post your question in the chat and we'll pick it up afterwards.
So yeah, Atkins are looking at the moment of how we can improve or reduce flooding on site. So some of the main things they're doing is clearing silt from this stream here. So we cleared the vegetation last year, but still build up of somewhere between some places 400 to 800 mil of silt. Obviously, greatly reducing the capacity of the volume of water that can flow through that stream. We're looking at potentially turning up pumps. One thing I haven't mentioned at the western port end is 2 pumps, which anything that starts to surcharge the 6-foot drain flows out into a stump on this downstairs. That then pumps water out 100 litres a second. Along with that blue line goes and out through and through. So we wanted to see if we were to increase that to 150 or 200 litres a second, will that first of all help us reduce flooding on the track? Highly likely. But is it going to have a downstream detrimental impact? Because obviously if we want to turn it up, we'd have to get a FRAP, and the EA are probably going to say no to us if we start to flood downstream. And the other main thing they are looking at us at the moment is removing the restrictor plate from the outfall of the 6-foot, which I'll come on to shortly. But that's obviously one big area that we're working with at the moment. Perfect segue. The restrictor plate. So, as you can see here, so this is roughly where we're on site. So that's the lagoon that's been constructed. 6-foot drain outfalls out through here into the Kingrove stream, which you can see there. That's what it looks like on site now. So one of our new cameras. This is an overflow from the downset, so you can ignore that. It's this side here. So it's 800 mil brick arch drain. However, it's an orifice plate which restricts that down to 300 by 250. So we're restricting the flow from roughly 700 litres a second down to 200 litres a second. The problem we get is when that groundwater flow is obviously really, really high, that drainage is full, but it can't all discharge. Therefore, it starts to back up and then it will surcharge into the track formation, then goes into the downcess and the upcess drainage, which then flows into the lagoon, taking capacity out of the lagoon, which is not what it's designed to do. The whole idea of this 6-foot drain is it flows all the way out into the Kingrove. The lagoon manages the up and the downcess, which is the overtopping of fluvial and fluvial water flows. So we're trying to model the moment how much benefit we get out of moving that restrictor plate, and yeah, what's the detrimental impact, or hopefully no detrimental impact downstream. I think I've got another fantastic drawing here. This is me trying to explain what I just said there. This is the 6-foot drain, but your downcess drainage, your upcess drainage. This gets full, it then starts going to transformation. The water level just starts rising, then it goes into our cess drainage, which goes into the lagoon. So the lagoon's used to have taking capacity what it's not supposed to be doing. So we have in week 15, so in 4 weeks' time, a week of possession along this section of track to do further bits of work. So there is some track drainage refurb in the tunnel ongoing. So we've got some very catch pits. So they will be raised, some clearance, because over years, ballast gets fallen in. I'm not saying someone's thrown it down there, but ballast falls into the 6-foot drain, and it kind of gets it's very calcitic as well, because there's Neolithic limestone. So that all then gets jumped together. So it needs breaking apart and pulling out, therefore increase capacity within the drainage system. That's one element. Another element is to improve those western portal pumps, because one broke in January, the other's the same age, so that's likely to break as well. The main element is this trap lift. So this is the track extent you've got. This is the aqueduct here. You've got the bridge to low mileage, tunnel pulls around about here, and you've obviously got some S&C here. This is the entire section that is now being lifted. So this red box though is our main area where it floods, and where we are mostly concerned about. So you can see on the down line, we are raising it by 250 mil, which is roughly about where that is. Sorry. So during wet, we said new aqueduct it was installed. Track was also lowered, obviously for the clearances for the OLE. As we have now been informed, we don't need as such strict tolerances on the OLEs, therefore we are now allowed to raise the track a bit. We are doing a little bit of work to the OLE arms. This is where my expertise are, so we're doing something to make it that we can now lift the track by 250. Any further questions? Don't ask me. So yeah, we're raising it by 250 mil on the down, which is roughly about the same height of what the up is now, as you can see here, not raising it by too much. However, interestingly, towards lower mileage, we're raising it more on the up than we are on the down, which is interesting purely because when we've been on site, we've noticed that the up floods before the down does. That's actually going to create a lot of resilience as well. Might not sound like a lot, 30 or 40 mil, but when it's not quite reaching the top of the railhead at the moment, you can actually 40 mil, and it definitely won't. So it does add a lot of resilience. And then obviously, again, just shows that down is still being lifted by more than the up as we go towards high mileage S&C. So the playbook that we're creating at the moment, this is being done with the local railways team. So we are, go back to the last slide. This is kind of how it's been broken down at the moment. We're in the data and information gathering phase. So it's going out and speaking to different teams, doing one-to-one meetings, understanding what their issues are. When they had issues, so we had Storm Barratt in November, where we had about 0.75 meters worth of flood water on the track. So it created catastrophic issues. We had earthwork failures, EMP assets were, so the local cabinets were flooded, burn on the 650 volt cable. So on the back of that, we started to try and work out when their issues arise. We're in that data information gathering phase. We'll then start making sort of flow charts, and we'll do basically break it down to 4 flow charts. So it's proactive, so severe flooding. So you've got a severe weather event coming in like Storm Barratt. We can either do something proactively because we know it's coming, or it kind of hits us last minute, so we have to be reactive. And the same thing with sort of minor flooding. So we're going to make those 4 flow charts. And the final version is just us trying to make sure it works. Let's go to the next slide. One thing that does come out of the data and information gathering phase is making these individual asset resilience plans. So what we need to get there on the left is what we're initially going to do now, sort of operational decision points. The next, what's going to go live in September. We then can work what we can do to make things more resilient, not just operationally, but physically doing engineering works. Short-term plans, so the next 4 weeks to 2 or 3 months, longer term, sort of next 2 or 3 years. Ever evolving space. I had a meeting on that after I made the slides yesterday. I had a meeting today, and it's kind of changed on that. So maybe I should have included that slide. Next slide, please. Just a brief point on what we're looking at in phase 2. Again, I feel like this might change as we get a bit more information. But so the current area of interest, the blue box there. So to the east, we're looking to reinstate some pumps. There used to be some there. They were taken out of service about 20 years ago. What we're looking to do is reinstate them, but about 6 chain into the portal. There's a great spring. That's one that roughly is somewhere between 1,000 and 1,500 litres a second comes into the tunnel. We're looking to try and take that, instead of pumping it down gradient, we're trying to pump it up gradient out towards the eastern portal. Therefore, discharging to a separate catchment. This goes into the Avon, I think, whereas it obviously goes through. So this is 2 very different catchments. So hopefully we can get it in that way. down to where we can get flooding. As I mentioned on that last slide, some of the long-term resilience plans from those one-to-one meetings we've got. So we're going to do some work there, freezing low cabinets next year. That's the plan anyway. Take them out of flood water, that means at least if the floods, we haven't got such an issue. And then we're also doing some natural flood management and nature-based solutions upstream of the catchment. The main point, or main thing to look at here, this is technically not on our land. It's not on Network Rail land. This is all off track. So this working with landowners, EA, council, to try and install measures which can basically hold water in upper catchment. If you store water in the upper catchment, up to about 1 in 5, 1 in 10 storm event, it won't really impact. You won't see any difference downstream. So it holds water in the upper catchment. And it's considerably cheaper than doing work on the railway because it's not on the railway. So it's really, really helpful. Anyone who's new to nature-based solution, these are some different things you can do for it. So it's creating like leaky dams. So water still gets through, but just stores water in the catchment for a little bit. Reconnecting the floodplain restoration, so like reconnecting floodplains. So where you've had channels have been sized, therefore as soon as water level gets high, normally it would go into the floodplain, but you can't do that anymore. So it's about trying to find a way to use that floodplain. Obviously, farmers will do some of their land, so they need to be compensated for that. And there's things like soil and land management, using runoff pathways, scarps and land, things like that. So it's all sort of stuff we're working heavily with the EA and Natural Resources Wales in Wales for. So yeah, in summary, we have so during phase 0, roughly 35 to 40 tonnes here of the track drainage system. So obviously created a huge capacity within that drainage channel. So the new chamber toe of the cascade of the flume drainage I mentioned. So we did spend roughly 900k during phase 0, which saved us roughly 11,000 minutes, or what equates to about £3 million. So we've already seen that the money we've spent has already returned itself 3 times over. Obviously, we've got a lot of multi-asset work coming up in 4 weeks' time, running through to about September, October. So hopefully we'll have a similar benefit as well. And then, we're moving towards phase 2 later in the control period. I think that's everything. Thank you.
We do have one question already online, so should we do that one first? Question around interface with the Environment Agency. Alex, do you want to come off mute and talk us through your question?
Hello, can you hear us?
Yep. Yeah.
Excellent. Yeah, so there's a few of us in the room here. We're in Bristol. So yeah, we were just wondering about because obviously with the removal of the plate, there's quite an urban area and quite a few properties downstream, and obviously that's where the concern is in terms of overflowing there. So yeah, we were just wondering about working with the Environment Agency and how that was going.
Yeah, cheers, Alex. Hi, Mark, as well. There's no you in the room there.
He is here. You may have guessed.
Actually, been scribbling notes away like crazy as well. So yes, we have reached out to the EA. We've already showed them early results of what we've got. Also, see Alex is aware. We have Network Rail NR and EA liaison officer. So do work quite closely with him on things like this, and I think he is keen for the idea. So what we're going to do is remove the restricted plate, but instead of just removing it completely, is put a sluice gate on. So if we can control the amount of flow through it, instead of just letting it go at 700 litres a second. Maybe whilst the river levels are low, we'll have it going at 700 litres a second, but when river levels are high, we'll restrict that down to like 200. The modelling is showing so far that is a positive thing, and we are desperate to get this done by September, October time. Trying to get a FRAP can take sometimes 4 or 5 months. Working with the liaison officer, it was his idea that if we've got the modelling to show that it's not going to have a detrimental impact on stream, that we will install this measure whilst we're actually getting the finalised permit. So yeah, it's all going rather well, Alex, at the moment. But the modelling results and everything comes back 6 weeks' time.
Okay, thank you.
Have any questions in the room? Yep.
I mean, I don't wish to sound pessimistic, but ultimately, it sounds like, despite all the good work you're doing, you're not going to be able to stop it from flooding on occasion, are you?
So, as the point I probably didn't make about the track lift, the track lift isn't supposed to stop it flooding. It's supposed to minimise the impact of flooding on the operational service that we can deliver. So sometimes we've seen that probably only like 50 mil of water above the railhead. In that lowest point, so if we're raising it by 250, yeah, you're right, we're still going to get flooding within top of sleepers, but we can still run trains. So it's only sort of a short-term measure, only sort of fixed maybe 50 to 70% of the time with flooding. And there's further measures we need to do to stop it flooding altogether. But yeah, you're right, it's just try and make it so we can keep it open more often than having £10 million Schedule 8 in one winter.
Yeah.
I guess that battle will keep raging on as climate change, heavier rainfall events, that 250 could quickly get eaten up in the future, couldn't it?
But very, very quickly and very easily, which is part of why we're trying to kind of work these MDS and NFM solutions upstream. Positive. And on your point there as well, in September, 4 days apart, we had 2 storm events, which were classed as between 150 and 100. 4 days apart, so hardly 1 in 50 events are there. So, yeah, we're already seeing the effects. The effects of climate change and the detrimental impacts they're having. So it is water management is never ongoing battle.
Any other? Yeah.
What sort of climate change allowances being included on the modelling for phase 2?
So we are modelling for 1 in 20, a 1 in 50, and a 100. So we're trying to make it resilient to 1 in 50. I'd like to make it resilient to 1 in 100. However, looking at Storm Barratt, which is around about 100, we had almost a metre of flood water on the track. I don't think we're going to stop those events, but it's about, again, same before, not making it resilient. The huge issue we had after that Storm Barratt, we were shut 7 days afterwards. Was because those low cabinets just basically got burnt out because all the water was inundated. But if we can lift the low cabinets out of the flood water, we don't have that issue. It just means we've got to wait for the flood water to go. Instead of it being 7 days, it's a day and a half. Then we can reopen again. That's the kind of, at times, it's like a mind shift. We're not trying to necessarily stop it flooding all the time. We're just trying to limit the impact. It means that we can reopen the line quicker.
It's availability, isn't it?
Yeah.
Yes. No more online.
Sorry, does Alex have a second one there?
Yes, Alex, you're yes.
Yeah, it was just about the phase 0 refurbishment works and sharing the outputs with the asset management team, and how much of that all been shared.
I think some of it has been done informally. I don't think all of it has been formally shared with you and your colleagues sat in that room. So yes, that will be done.
Okay, cool. Thank you.
Is there any option to drain to the west in terms of pumping it through that?
Something we have strangely looked at, yes. So 6-foot drain does run all the way through to Westerly, and there is a bit of, I'm going to call it scrub land, but land that isn't really got many houses around it, and I don't know how big the area is, but we could flood. In terms of trying to pump water that far, that's how feasible it is at the moment. We haven't gone into any feasibility studies and understanding it, but yes, it's an approach that we might take. Our issue we do have is surface
Pump it up to the top of the cutting and then you could run into gravity if you required other people's land.
Probably got a lot of third parties and not a whole lot of space at the crest of that section.
It strikes me if that will built a nice rowing lake for the people of Chipping Sodbury, downstream of Chipping Sodbury, and filled it up, they'd be very pleased.
So I guess pie in the sky, what would be great would be working with Wessex Water, and we do a large amount of extraction from that groundwater, below that groundwater table, and a pumping station up there, or basically a water station, Wessex Water, to then utilise all of that water that's coming out of the ability limestone, then that would help us greatly. I've no idea how feasible that would be.
There's a scheme
It's a
about
quarry at Yate needs filling.
there's a scheme about 10 years where they're looking to sell it to the badminton estate. We're hoping to sell water to them, but I don't think it ever happened. Pumping it eastward is quite a good idea.
With the so the different systems and the different monitoring and the various locations, how much of that will enable sort of automated processes to manage flows of water in different directions?
Yeah, that is where we would like to get to. So we are, with all this flow monitoring we've got out, by the time we'd actually got in properly installed was about February, and then it basically hasn't really rained that much since. So all that flow monitoring's really given us any data yet. This winter we'll actually get a lot of information on the flow monitoring. We'll then understand kind of which stream gets affected worse, which gets affected first, not much worse. And then we kind of want to start aspirationally again, sluice gates sort of all over these different streams. So again, we can manage the flow. And then, yeah, I took the slide out, but the aspiration is for AI to then manage. So with machine learning, you can go, so that stream now is getting really, really high. Let's turn off the groundwater pumping, and then let's make sure more water can go into the track drainage. Or no, right, okay, we just hold back water in the balance of the pond. Let's turn up the pumping from the groundwater. But instead of us doing it, it'll be an AI-led scheme.
It's phase 6.
That's phased a lot, yeah. Need a lot of technology for that, I think.
Yeah. Brilliant.
George, thanks. You've done a lot of really good sort of maintenance type work, haven't you? Clearing the vegetation in the stream and also unblocking, was it the culvert, the cross drain? Yeah. How involved are maintenance in gearing up to take on, as it were, the ongoing maintenance? Because in the past we've seen projects where we put a solution in and then 10 years down the road it falls down because we haven't looked after stuff as we should have.
Yeah, I guess the good thing with that sort of playbook that I'm doing is I'm going out and speaking to all these maintenance teams, so I'm actually sort of building that rapport with them. So when we and in those conversations, we are already mentioning the work that we've done and what needs to continue.
Yeah,
and I think they seem to be very open to the fact that we need to do that, and once we get it back to where it needs to be, let's not let it degrade to where it was 2 years ago when we sort of stuck in. So I think there's for another year or so of sort of our team being on this, and then exit strategy, giving it back to the asset team to go.
Right. Okay.
Cool.
Start the lineup.
We've got one question about the name change. So
Yeah, do you want to fill that?
yeah, so Michael James asked about the name change and why we're not including the word infrastructure in the new name. That's a deliberate choice by the PWI board. We're trying to be inclusive of all people involved in railway engineering, not just so we're not the Institution of Railway Engineers, we're the Institution of Railway Engineering, because we want to include people like project managers who are involved in engineering projects. If they want to join the PWI, we want to welcome them in. But the reason we haven't included infrastructure is simply because it's more jargon, and what our feedback we get from, particularly from young people who are maybe leaving university, looking at when a lot of people join an institution before they join the railway industry or when they join the railway industry. So they once they're in, they tend to stay wherever they are. It's a bit like a bank. Once you join your bank, you stay there for years. So we need to get people at that point in their career. And the more jargon we add to the name, the less relevant and understandable we are to those young people because they don't understand the railway industry and the ins and outs and the structure. As far as Michael's question about the RSE, we're not treading on the RSE's toes. It's not our intention. We're welcoming of signalling engineers. We want to include signalling engineers as well as track engineers, electrification engineers, and all the other.
Interestingly, last week we're talking to the IRSE have been heavily involved in agreeing that proposed name now. So, and they're also now collaborating with the PWI on training events for multidisciplinary. So around S&C, for example, training events that will be hosted jointly by PWI and the IRSE. So they are on board with the proposal, and it's been through all the legal challenges. It's they're happy with it. Yeah.
Michael, I hope that answers your question. As I say, there'll be a vote. As Nick has said, there'll be a vote probably late this year or maybe early next year. We will be there. You'll be receiving a lot of communications about the vote. Please do vote. Whatever your views are, please vote.
Yep, brilliant. So thanks for that today, George. For me personally, I remember going back 20 years, walking through that tunnel in Waders, tapping bricks and various other things. So, it's since it was built, it's flooded. So it's about time somebody tried to manage it a little bit better. So it's good to see, particularly with climate change and new challenges coming all the time. So that's good. And I think for everybody who works and lives on the region, it's nice having a West of England presentation because we've had a few off-patch ones recently. But for us who live and work on this route and this region, this is a key asset, and its availability for us as passengers it is key, really, for moving people around the route. Never mind for us who work on the route, and we're doing our best to minimise train delays for those that are travelling. So, brilliant project. Thanks for coming along, and look forward to seeing you all back for another meeting soon. Cheers.